Let me consider a situation today in physics where Ahmed, after skydiving, landed safely on the surface of Earth. I'm gonna forward you a question here. What is his acceleration due to gravity? What I mean is, what acceleration due to gravity does he produce? At your best, you're gonna tell me that, sir, he produced an acceleration due to gravity that is equals with 9.8 meter per second square, right? So this gonna be our exact discussion point, how to calculate mathematically the value for g, which is equals with 9.8 meter per second square. Hope everybody got me what the topic will be today. All right, and I have few more question. I have few more question in my plate, like, is this value for g is constant or is it changing? If it is not constant, on what factor does it depends? Is this value remain same in moon and other planet? So we're gonna definitely address this question in today's session. Let me stick to the topic, how to calculate the value for g. Now, since we are calculating the value for g, everybody, we need a formula, right? And the formula that gonna help us to calculate the value for g is given by a relation of capital G and small g. Now, what was capital G? Let me recall. You're gonna tell me, sir, it was universal gravitational constant, right? And what's the value? It was 6.673 into 10 raised to power minus 11 Newton meter square per kg square, right? Whereas the value for small g, acceleration due to gravity, was 9.8 meter per second square. Now this both will give me a relation. That's the formula here, and that will help me up to calculate the value for small g. And the formula is given by small g equals with capital G m by r square, as you are seeing. So this is the formula we got. Now since we are calculating for Earth, what is this m? You will tell me, sir, m stands for mass of Earth. What is that? R stands for radius of Earth, right? What is g? We already discussed. It is universal gravitational constant between two objects. All right. So what is next then? Next will be how to derive this formula. So once we derive this formula, after that we're gonna calculate the value for g. Good morning, everybody. I welcome you in classes with Brilliant Group of Institution, Doha, Qatar. You got a very clear picture today what we're gonna do. Let me frame it again. We are here to calculate the value for g. All right, and I have few questions in my plate. Is this value for g is changing? If it is changing, on what factor does it depends? Is it depending on the mass of Ahmed? Is it depending on the mass of Earth, or what? So these are the questions we're gonna address in today's session. We need a formula. We need a formula to solve. And what is that formula? You're gonna tell me, sir, small g is equals with capital G m by r square. Next case is how to derive this formula. So learn it. It's gonna give you 3 marks in exam. Let me consider an object, or let me take back Ahmed, right? Let me take him back where he was on the surface of Earth, right? Let me consider mass of him be small m, right? Let me consider mass of Earth be capital M, right? And the distance between Ahmed and Earth will be its radius. So mark this point. The distance between Ahmed and Earth gonna be its radius. There you go. Once again, I consider mass of the object. Who is the object right now? Ahmed, right? Is small m. Mass of the Earth, capital M, and the radius is the distance between them, that is r. So this I write it very beautifully in introduction part. Is it mandatory? You're gonna tell me yes, sir. Yeah, it is mandatory. All right. Descriptive exam, everything counts. So what is the introduction? I'm gonna let us consider an object. Who is the object? Ahmed here, right? Of mass m, a bit quick, on the surface of Earth, right? So I'm gonna take over here mass, capital M is the mass of Earth. All right. So here you're gonna tell me R. What's R? Radius of Earth, right? I'm gonna put in a bracket. So that's the beauty. You need to tell everything what you are writing here. Here radius of Earth, right, is the distance between them. So what I gonna do next? So in this entire situation, I gonna apply universal law of gravitation, and you have to recall what was that. So according to universal law of gravitation, I'm applying here. According to or applying universal law of gravitation. So you will tell me that the force gonna be equals with capital G, both the mass product divided by distance. Now distance was the R, we have been discussing it, R square. There you go. What was this? This was universal law of gravitation. Okay, the beginning part of the chapter gonna help you out how you get this. Once again, what I did in the entire situation, all right, I applied universal law of gravitation and I got F is equals to G, product of Ahmed mass and Earth mass and the distance between them. There you go. Right? That's the relation. Next case, I'm gonna apply formulation of Newton's second law, everybody. I'm gonna apply formulation of Newton's second law. Now, what was that? I'm gonna ask you was, all right? Why so? We already studied in the second chapter, right? You're gonna tell me, sir, F is equals with M into G. So what's G over here? Address it. G stands for acceleration. So write it full, acceleration. I'm writing it short like that. Acceleration due to gravity. Right, guys? I'm gonna make it equation number 2. Okay, so what I did is very clear. I consider an object on the surface of the Earth. Who was the object? Ahmed, consider yourself. Let me consider myself where I am on the surface of the Earth right now. What is my mass? Small m. Mass of the Earth, capital M. What is my distance with the Earth? You're gonna tell me, sir, it's radius of the Earth. All right. What I did after that? In this situation, I applied universal law of gravitation. There you go. What I did next? I did applied formulation for Newton's second law. There you go. All right, F is equals with mg. So this is it. This is it. Now you clearly see that. You can clearly see that what I mean is both forces are equal. Now since both forces are equal, the corresponding value should be also equals with each other. Yes or no? Yes or no? Getting me? So both forces are equal. Therefore, mg. I'm gonna make from 1 and 2 from equation 1 and 2. All right, mg will be equals with capital G m into m divided by r square. Now all into 2 is take the value for m downstairs. Which value? I'll show you. This m, you need to take it downstairs. That's what you will do when you simplify the value further. So you can clearly see masses are cancelled. Now I'm gonna ask you, somewhere in the starting of the part I asked you, does the value for G depends on mass of Ahmed? Can I take this argument like that? Does it depends upon my mass? Or can I take this argument, does it depends on your mass? So you're gonna tell me no here. Why so? So clearly you can see both the masses are getting cancelled. Now what is this mass is for? The object, right? Ahmed's mass is getting cancelled. So value for G is not depending. We don't want that mass. We don't need my mass. We don't need your mass to calculate the value for G. I guess you're getting me a very clear picture. All right. So that's how we will address. That's the beauty of physics, right? Next case, G becomes G m by r square. There you go. This is how you did calculate it. You did derive the formula which will help me out to calculate the value for G. Alright? Now clearly you can see it. On what factor does it depends? You will tell me, does it depends upon mass of the guy, Ahmed? No, it's not depending on its mass. Then it's depending on what factor? It's depending on mass of the planet. Mass of the planet, alright. It is depending upon the radius of the planet, whereas universal gravitational constant is the constant value. Alright. So you're getting me? Let me reframe once again what we have been doing. So we were here to calculate the value for G. Alright, that is equals with 9.8. We're gonna see it whether it is changing or remaining constant. Alright, is it depending upon the mass of the object? You're gonna tell me now. No, right? Just now we have seen it is getting cancelled. Perfect, very good. After that, we addressed which is the formula will help us to calculate the value for, help me to calculate the value for G, right? That is 9.8 meter per second square. Perfect. And then I figure out how to derive the formula. So have a look. That's how you derive. You created a situation object on the surface of the earth. You applied universal law of gravitation, Newton's second law. All right, have a business here. After that, you simplified to get the value for G. Okay. So next case was how to calculate. Now this is gonna give you 3 marks. Please practice it. Now what is the next one? Next one is the calculation for the value of G, our main topic, right? How to calculate. Is it comes in exam? Yes, of course. How many marks? All right. So it will also give you 3 marks. So what was our formula? Just now we have seen, sir, G is equals with G m by r square. All right. All right. So what is needed? So you will tell me that, sir, we know. You have to know right now. I know. You have to know as well. What you need to know? Mass of Earth. So we need to by heart it? Yes, of course. All right, you have to. Mass of Earth, capital M, gonna be equals with how much? You will tell me, sir, 6 into 10 raised to power 24 kg. All right. What is radius of Earth? Remember, radius of Earth was the distance. R is equals with how much? You will tell me, sir, 6.4 into 10 raised to power 6 meter. All right. Next one, what was value of G? So universal gravitational constant has a value. All right. I told you orally when did I started the class today. Right now I'll write it for you. What was that? 6.673 into 10 raised to power minus 11 Newton meter square. Okay, per kg square. So this is it. This is it. You can clearly see on what factor the value for G depends. All right. Now rest is our calculation. Once we calculate it, my answer should be 9.8 meter per second square, right? So let's start. Do we need to by heart this once again? Of course, we need to by heart those value. All right. See next. What is G value? 6.673. But when you put it in a formula, you need to take a round of value of 6.7. All right. Into 6.673 becomes 6.7 into 10 raised to power minus 11. All right. Into mass we have how much? 6 into 10 raised to power 24. Okay. Divided by radius square is how much? 6.4. All right. Into 10 raised to power 6 whole square. Perfect. So what you gonna do next? You will simplify. So let me arrange it. 6.7 into 6 into 10 raised to power minus 11 plus 24. All right. Divided by 6.4. 6.4 is a square. So I'll make 6.4 into 6.4. So check it over here what I used in this form, in this place. So everybody know a raised to power m into a raised to power n gonna be equals with a m plus n. Right? This much maths everybody knows, I guess. So minus 11 plus 24, that's what I did. So what is next then? So next is the square term. So I made 6.4 into 6.4 into, all right, 6 into twice, it's gonna give me 12, right? So a raised to power m, right, n will be a multiple value like that. Correct? So what is next then? Next we can cancel this value with 2, right? 2 how many times? 3 times, and it goes how many times? 3.2, correct? So after that, you're gonna multiply 3 into 6.7, right? 3 7 times 21, 1, 2, 3, 6 times, 18, 19, 20. So you got 20 and you have a point over here. There you go. Okay, after that, 10 raised to power minus 11 plus 24, right? So this will give me 10 raised to power 13 divided by, okay, 6.4 and 3.2. I did many times in my life. You will get 20.48 into 10 raised to power 12. So have a close look how my number gonna change now. I will shift it in upside, and you know that a raised to power n, if you write it together by shifting this n, right, it becomes a m minus n, right? So you're gonna do the same thing. That equals, okay, have a look, I'm going a little bit slow. So 20.1 into 10 raised to power 13 minus 12 divided by 20.48. all right, so how the number will be now? So I'm gonna take it here little bit, the calculation. So I'm gonna take it here. So we were calculating the value for G. Perfect. So what is that? This is what we have the value. All right. So 20.1, 10 and 13, what you will get? So 20.1 into 13 minus 12, so 10 divided by 20.48. All right. So what you're gonna do next? You'll multiply both. You get this number, right? Divided by 20.48. Now I'm gonna see I will multiply upside down with 100, right? Why I'm doing so? Because I'm removing decimal, right? So 20.48 into 100. So what's the result? You will tell me 20100 divided by 2048. Now clearly you see this is 20,000 and this is 2,000, 20,000 and 2,000. So when you divide it, you're gonna get your answer to be, you keep it up to here, meter per second square. Beautiful. So you got me how to go with this today's class we discussed, right? So what was the discussion point? We were discussing once again how to calculate the value for G. All right. Next we were figuring out the formula to calculate the value. Next we derived the formula, very important point, 3 mark. All right. Next we calculated the value of G, once again important, 3 mark. All right. Then you remember I did ask you a question that I have a question in my plate. This value of G remains constant. You're gonna tell me no sir, the value of G is not remaining constant. Right now we have got a formula. What was the formula? G is equals with G m by r square. Okay, first fact is it is not depending upon the mass of the object. You remember Ahmed? It's not depending on his mass, right? Because mass and masses was getting cancelled here. Correct? Then it depends upon what? You will tell me, sir, mass of the planet and radius of the planet. So what you will do if I ask you the same question, calculate the value for G in moon. Of course, you will take mass of moon, you will take radius of moon, and you're gonna calculate it, whereas G value is constant. Is it same? You're gonna tell me no, sir. Since the mass of the planet doesn't remain same, all the planets have the same mass. No. All the radius of the planet have the same same length. You will tell me no. Getting me? So this value of G will be vary from place to place. In fact, it is varying in the earth as well. All right. So you need to know the shape of earth for that. All right. So once you get the shape of earth, you will find out the radius of the earth doesn't remains same. Because of this factor, it gonna change in pole and equator. So that's a homework for you. You figure it out how it is changing. All right. Of course, I gave you the answer already that the radius of the earth doesn't remains same in pole and equator. So that makes the value for G also change in pole and equator. All right. So hope everybody got the class, right? Let me reframe. This is so important of framing the things back. All right. I was here to calculate the value for G. That was 9.8, right? I got a formula. It's a relation. Okay. Then I got a derivation. All right. And finally, I did calculated the value for G. And I figure out some important conclusion that this value for G doesn't remains constant. It's going to change place to place depending upon the mass. All right, and the radius of the particular planet. So this is it from my side. Okay, we're gonna see with another episode of physics. Till then, take care.